We're looking at homework from section 6.2. This is question number 13. Use the standard normal distribution, or the t-distribution, to construct a 90% confidence interval for the population mean. Justify your decision. If neither distribution can be used, explain why. Interpret the results. In a random sample of 49 people, the mean body mass index, BMI, was 29.8, and the standard deviation was 6.08. First question, which distribution should be used to construct the confidence interval? Choose the correct answer below. Well, to answer a question like this, we need to focus on the standard deviation. Is it a population standard deviation or a sample standard deviation? So it says, in a random sample of 49 people, the mean was 29.8 and the standard deviation was 6.8. So that standard deviation is in the sample, so it's a sample standard deviation. That means we don't have the population standard deviation value. Since we don't have the population standard deviation, we can't use the normal distribution, so that eliminates choices B and C. So now we're thinking it's a t-distribution, so let's look at the t-distribution choices. A says use a t-distribution because the sample is random, n is greater than or equal to 30, and sigma is unknown. That sounds pretty good. D says use a t-distribution because the sample is random, the population is normal, and sigma is unknown. Well, we're not told that the population is normal, but we are told that the sample is greater than or equal to 30. So we're going with choice A here. Use a t-distribution because the sample is random, n is greater than or equal to 30, and sigma is unknown. What about the next part of the problem? Select the correct choice below, and if necessary, fill in any answer boxes to complete your choice. So we want to build the 90% confidence interval. It's not going to be that neither distribution can be used because we already said that we can use the t-distribution. So we're going to use that t-distribution and find the degrees of freedom. Degrees of freedom are n minus 1. The n in this problem was 49. So we're looking at 49 minus 1, which is 48. So we need the t-distribution now. We're going to look for where the degrees of freedom 48 intersect with a level of confidence of 90%, and that happens at a value of 1.677. So that's our TC value. Once we have the TC value, we need to find the error. We use the margin of error formula that error equals TC times S over the square root of n. The TC we just said was 1.677. Standard deviation was given to us as 6.08, and we had a sample of size 49. When we multiply this out, we get 1.456594286, and when we round to 2 decimal places, that's 1.46. Once we have the error value, we can form the confidence interval by subtracting the error from the mean and adding the error to the mean. So our confidence interval is going to be x bar minus the error to x bar plus the error. Now the x bar value that we had was 29.8, and the error that we came up with was 1.46. So this is 29.8 minus 1.46, 29.8 plus 1.46, which gives us a 90% confidence interval of 28.34 to 31.26. So we're choice A, and we insert our answers. What's next? Well, we need to interpret the results. Choose the correct answer below. So when we find a confidence interval, then we are that confident, whatever the level of confidence is, we're that confident that the actual population value falls within the given interval. So let's read through these. If a large sample of people are taken, approximately 90% of them will have a BMI in that bounds? No. It can be said that 90% of people have BMI between the bounds of the confidence interval? No. With 90% confidence, it can be said that the population mean is between the bounds of the confidence interval. That's what that means. When we're finding a confidence interval, the level of confidence is how certain we are that the actual population mean falls within that interval. So we're going to go with choice C here. And that's your answer.